in problem 10, we have an optimization problem dealing with a cost function given by 5,000 plus 300x plus x squared. So here x represents the number of goods produced. So in the first part, where they asked us to determine the average cost function, so when you average something, it means you total everything up and then divide by the number of things, right? So here the total is the total cost, and the thing we want to divide by is the number of units. And so the average cost so the notation is C bar is calculated as taking the cost and dividing by x. Okay, so C of x is the function. So 5,000 plus 300x plus x squared. And we divide the whole thing by x. And so dividing by x means every term gets divided by x, right? So it's 5,000 over x plus, and then here the x is canceled, so it's just plus 300, and then x squared over x is just x. Okay, so this is C bar. And they also want us to calculate the average cost to produce the average cost to produce 20 units. So here x is equal to 20. So we just plug that in and calculate. So 5,000 divided by 20 plus 300 plus 20. So what is this equal to? So calculating this. So 5,000 divided by 20 plus 300 plus 20 is equal to 570. Okay, so so that's part A, and then now part B asks us to minimize the average cost and then find the minimum average cost. Okay, so to minimize something, we need to find the critical points, right? So we need to take the derivative of the average cost, which is this function here, right? So to make things easier, I'm going to think of the x in the denominator with a negative exponent, right? So C bar is equal to 5,000 x to the minus 1 power plus 300 plus x. So now when I take the derivative, I just apply the power rule, right? So minus 1 times 5,000 x to the minus 2, because you subtract 1 from the power. And then derivative of a constant is 0, so that term goes away. And then here the derivative of x is just 1, so you get plus 1. And I want to find the critical point, so I set it equal to 0. Okay, so you have minus 5,000 over x squared plus 1 equals 0. So now I need to subtract 1, so you get minus 5,000 over x squared equals minus 1. Now I cross multiply. You get minus 5,000 equals x squared minus x squared. So cancel out the minus sign, so you get 5,000 equals x squared, and then now I just square root both sides, so I get x equals, So what is the square root of 5,000? So about 70.71. Okay, so again, X is the number of units produced. So if you produce about 70.71 units, that will minimize the average cost. But if I want to calculate the actual minimum average cost, I need to take this X and plug it back into the function. So so let's calculate that. So 5,000 divided by 70.71 plus 300, right? So I'm plugging it into this formula here. So plus 300 plus X, which is 70.71. And so let's calculate this. So 5,000 divided by 70.71 plus 300 plus 70.71. Okay, so you got 441.42. So that's the minimum average cost. Okay, so so as usual, when we're trying to find the maximum or minimum of something, we can verify our calculation, right? So what is the function we're minimizing? So this function here, right? So 5,000 x to the minus 1 power plus 300 plus x. So let's graph this. So it's outside of this window, and you can see the x values are fairly large, right? So let's change the window. It doesn't make sense to make produce negative things, right? So let's say x max goes to 100. Okay, so we kind of see the shape of the graph, but it's not entirely clear where the minimum occurs. So let's make the x bigger. Right, so you can see that the graph goes down and then it starts coming up here. So the minimum should probably be around here somewhere, right? So let's calculate it. So let's play it safe, put the left bound pretty far to the left, and then the right bound pretty far to the right, where we can see that the graph is starting to increase again. And guess it's probably about here. And we see that the minimum occurs at 70.71, and the minimum value itself is about 441. Okay, so this is problem 10.